Assalamualaikum. Good morning, everyone. Today I will be talking about the input and output of microcontroller. As you already know, the microcontroller cannot do the work by themselves. They need some devices, which is input and output. So today I will be focusing on the understanding input and output. Now we will start with the understanding the output. As we know that microcontroller can perform some processing. Yeah, microcontroller can do many things. However, it needs some input and output devices. So if we do some analogy, the microcontroller can be analogized as a brain. You know, brain can do amazing jobs. It can recognize something. It can be used for thinking something. Yeah, but the brain requires some input devices like eyes, ears, nose, or skin. The brain can process something, but it needs input. Without some input devices, then the brain process nothing. So it's absolutely we need some input devices for the brain, like eyes to see, ears to hear, or nose to smell. So these eyes, ear, nose, skin serve as input for the brain. Okay, that's for the input. Okay. Now, if the input has been given to the brain, and brain can do some processing, but at the end, the brain does not connect it to anything, then it's become useless. Brain needs to be connected to the muscles as the output devices. Okay. By having them connected to muscles, then after the brain process some input, then the brain can command the muscles to do some works, like to move the feet, grab something by the hand, or something else. So this is I just want to show you that microcontroller is just like this. Okay. Okay. This is brain. The brain needs some input for processing, and after it's do the some processing, then it should output something. It can be in the movement of the arm, or the movement of the feet, or other motion. The same situation apply for the microcontroller system. The microcontroller is the brain. The brain cannot do the work by itself. The brain can only process something. It cannot do the real action. Okay. As I already told you that microcontroller, like the brain, it cannot do the real action. Yeah. Microcontroller can process and can give a command, but if there is no device that execute the command, then it's the end. That's finished. There is no real action has been done. What kind of real action? This is some example of the real action. The real action can be connecting or disconnecting switch. The real action can be a beeping alarm. The real action can be flashing light, rotating wheels, playing music, or moving door lock. This is the real action. I just want to remind you again that microcontroller cannot do the real action. it can only send command, but the command require some other devices, what we call output device, that do the real action. Okay. The output device basically is converts the command into text, into audio, into video, or into other forms. Okay. So basically the way microcontroller sends commands is by only change the voltage of its pin. So I already show you in the last week what is the microcontroller look like, and you can see there are many pins on the microcontroller. So the way microcontroller send commands just by changing the voltage of its pin, and the voltage itself is also clearly specified. So microcontroller can change the voltage. If it's not 0 volt, then it will be 5 volt. Okay. By having this voltage change, then the output device that is connected to the microcontroller through its pin, then the converts this information in the form of voltage into any action. Like if we want to convert the state of the voltage to the states of connection, is it connected or should be disconnected, then we need the module what we call a relay. Okay. If we want to convert from the voltage command to light, then we need LED module. If we want to convert from the voltage to sound, then we need the buzzer module. If we want to have the convert to the voltage that being given by the microcontroller into the text, then we need the LCD module, and many more, like voltage to music by using MP3 player module. And if we want to get a picture, then we need to convert from the voltage to picture by using the graphical LCD module. So because the microcontroller can only send command, microcontroller cannot do the real action. Microcontroller can only send a command, and the way it sends command by only changing the voltage on its pin, and then here comes the output device that convert this voltage information into the real action. Okay. So I just want to give you example like this. I want to highlight this one. So the microcontroller send the command by changing the voltage from 0 volt into 5 volt, or vice versa, from 5 volt into 0 volt. That's only voltage. If we want to have the state of connection, in here the real action is connecting or disconnecting switch, then the output device, which is a relay, convert from 0 volt into state of disconnected switch, and when the voltage changed by microcontroller into 5 volt, then the state become connected switch. So the output device to do this job is relay. The same thing for here. In here, if there is a 0 volt in here, so there is no music being played, If there is 5 volt in the pin of microcontroller, then the device will start playing the music. This is done by the MP3 player module. Okay, so the output device is the one that do the real job. Microcontroller cannot do the real action. There are plenty of the output module for the microcontroller, but if you understand this sum module clearly, then it might you can use this module maybe for hundreds of projects, because this is common. The output module, that common output module, is like this. For instance, the relay that changes the microcontroller commands into on and off. It can be connected to many things. Then you can control many things by using microcontroller. By having the LCD module, you can display many things. It can be the current, the voltage, or it can be the temperature, or many things. It can be in the LED module. If you want to have a flashing light or changing color, you can use the LED module. If you want to play music, you can use this one. If you just simply want to get the beeping noises, you can just using the buzzer module. If you want to display some measurement but only the number, then you can use the 7-second module. The 7-second module cannot display the alphanumeric. It can be only be used for displaying numbers. If you want to have to control motors, then you have to connect the microcontroller to the DC motor driver. This is for controlling the speed of the rotation of motor. If you want to control the position of the motor, then you need the servo motor, and then you need the different driver like this. So this is the very common modules. Lots of projects can be done by only just using this output module. For instance, the relay. Because relay converts the microcontroller's command into on or off state, then this is just become like the normal switch. As you already know, the switch can be connected to the AC lamp, or maybe the switch can be connected to the DC lamp, or the switch can be connected to the electric water valve, as well as the door lock. So by connecting the relay module to one of these examples, then let's say you can control the tap, automatic tap. You can control your accommodation door lock. So maybe if there is somebody coming, then the door locks will be open, or something else. Or you can control the AC lamp or DC lamp. There are many things that you can do with the relay module. Okay, the microcontroller, in this case the Arduino itself, cannot directly control the AC lamp. Why? The output is just 0 or 5 volt. It's not enough to drive the AC lamp. The AC lamp clearly requires the AC voltage. Even though if you want to control the DC lamp, you cannot do directly from microcontroller without the relay module. Why? Let's say this is already provide 5 volt, but maybe the lamp require 12 volt. So if you connect the Arduino directly to the lamp, the lamp still cannot on. Okay, the same condition apply to other this is other example. Okay, I already talked about the output. Now I'm going to talk about the input. So microcontroller can only process, but it requires input. Microcontroller needs to be able to sense the environment, whether it's temperature, humidity, light, or other things. Okay. So the input device for the microcontroller can be analogical as eyes, ears, or nose for the microcontroller. Okay. So it depends on your application. You don't have to provide all of these sensing device into the microcontroller. If you just want to tune the microcontroller to sense the temperature, then you just need to put the temperature sensor. If you just want the microcontroller to sense a light, then you just need to give the microcontroller some eyes. Okay, so it's not required to provide all of the sensor to the microcontroller. Just put what you need. And this is some examples of input devices. This is become eyes, ears, skin, or nose by the microcontroller. Okay. If you want the microcontroller to be able to see the light, then you need to put the light sensor. If you want to the microcontroller be able to hear something, then you need to put the sound sensor. Okay. If you want the microcontroller to be able to detect the presence of a people, then you need the PIR, etc., etc. There are many things here. Like it depends on your application. Let's say if you want to build the watt meter, if you want to build a watt meter, you know what is the multiplication between voltage and current. Then you need to buy the AC current sensor or AC voltage sensor if you want to build the AC watt meter. But if you want to build the DC watt meter, you should buy the different sensor. Instead of buying the AC current sensor, you need to buy the DC current sensor and the DC voltage sensor. So this is just some example. If you want to build the automatic, let's say automatic light or automatic heater, then you need to be able to sense the temperature, then you need to buy the temperature sensor. So the input and output devices are connected to microcontroller through this pin. You can see in this pin. Okay. So the connection is through the pin. So this pin is being used to connect to the input and output devices, but not just that. As you know, the electronic device needs to be connected to the power supply. So some pins in here is needed to connect to the power supply. So if I change the picture into like this, so in this picture you can see clearly about the function of each pin. You can see here there are many things. Now I'm going to cover the input pin for now. Okay, the Arduino requires some voltage, so you can apply the voltage for the power supply for this Arduino through this pin, voltage input pin. And because there is some regulator here, so you need to provide the voltage higher than 5 volts. You should give let's say 7 volt, 9 volt here, and then it will be regulated by the chips here, and then it will provide 5 volt for the microcontroller. Or you can also apply the direct 5 volt by using this USB. So you connect by using the typical USB cable to the power bank to here, then the Arduino is already get some voltage. So the USB, so the power supply can be applied from the USB or through this pin. Okay. And this 5 volt is the output voltage, not input voltage. This 3.3 volt is output voltage. That means if you already provide some voltage here, then there will be 5 volt output here or 3.3 volt here. The purpose for this voltage is to power the other device, but you need to remember the current is very limited. If your input or output device only require a low current, then you can connect directly to here. But if your input or output device require the higher current, then you need to provide the power supply directly to the input output device. Don't connect to this Arduino. So okay, so this is input voltage. Okay, the rest of the pin is where you connect the input and output devices. Okay, I'm going to change the picture to the other picture. Okay, so this one, as you can see, this is the voltage input, this is the voltage output. You can reset the microcontroller by pressing this button. Okay, but if you want to reset the microcontroller from the external button, then you can connect the button to this reset pin to here. Okay, and this pins is for digital input or output. This one is for the analog input, and that one for the communication. Okay. I'm going to cover in details in the next slide. As you can see here, there are some type of the connection. So it is color code. Let's talk about the easiest one, which is the power. The black lines here, if where the pin, if you want to connect the power, if you want to power the Arduino, the microcontroller, you apply the voltage input to this pin and to the ground. You can apply to this ground or that ground or that ground, all the same, because all of these pins are connected. So you apply, let's say 9 volt here with this ground, and because there is a regulator here, so the regulator then outputs 5 volts that's needed by this board. 5 volt and 3.3 volt is the output. You should not connect the 5 volt directly to here. Okay. This reset pin, if you want to connect the reset button, if you want to connect external reset button, it's already provided by the board here. Okay. So the black code of lines is for the power. If you want to connect the input and output, you need to do from the blue or the green one. The difference between the blue and the green ones is the blue pins, this one is for the digital input and output. The digital means the output can only be 0 volt or 5 volt. It cannot go in between. So the digital input or output only has two states, 0 or 1, or in the term of the voltage, 0 volt or 5 volt. So it only has two states. But for the analog, it can be many states, because it can go from 0 to 5 volt. From 0 to 5 volt. Let's say, if you want to connect the temperature sensor, the temperature can be 0 volt, 1 volt, 2 volt, it depends on the temperature. Let's say, if the temperature detected is 20 degrees Celsius, then the output is 2 volt. If the output, if the temperature is 25 degrees, then the voltage output is 2.5 volt. So in that case, you need to connect to the analog. But if your temperature sensor only provides two conditions, hot and not hot, then you just need to connect to the digital input. Okay, because digital input can only receive two conditions, yes or no, on, off, hot or not, just like that, 0 or 5 volt. For the analog, it can goes gradually from 0 to 5 volt. Okay. These three types of pin is the most important for the basic learner. Okay. But not just like that, there is some other pins that can be used here. The one of the type of pin is the PWM. If I summarize all of these pins into a table, you can see like this. Okay, for the output, it can be digital or PWM. If you only want to have output that provide two states, then you just need to connect to the digital output. Yes, no, connect, disconnect, on, off, or something else. But if you want to get the conditions, not just on, off, but also the condition in between on, off, let's say, I'll give you the clear example, which is the motors. If you want to control the motor, just on or rotates or stop, rotate or stop, then you just need the digital output. But if you want to be able to control the speed of the motor, 0 which is stop, 100 which is full speed, or maybe 50%, which is quite slow. If you want to faster, a little bit slower, a little bit faster, and then you need to connect the PWM. Other example, if you control the lamp, if you want to control the lamp just on and off, then you just need to connect to the digital. But if you want to control the intensity of the lamp, it can be fully off 0 volt or fully on 100%, but you can also want to get in between. You want to get the lamp a little bit dim, a little bit bright, more brighter, then you need to connect to the PWM. That's for the output. For the input, there are also two types. The first is the digital. For instance, the example for the digital input, like there is people, there is no people, there is people, no people, so only two condition. Hot, not, so only two condition. Bright, not, only two condition. So it's you can connect this input to the digital. But if you can get the measurement in between 0 to 5 volt, then you need to connect to the analog. If you want to feel the humidity, let's say it's not humid, a little bit humid, very humid, so you need to connect to analog. For the rest type of the pins is for the communication. So this type of pin provide communication if you want to connect your microcontroller to other microcontroller, and you want those two microcontrollers to be able to talk between each other. So in this case, you need the communication pin. Okay. What's the purpose then for the communication? Let's say if you have one microcontroller in the front of your house, and you have other microcontroller in the backyard for controlling, let's say, the sprinkle, the water, or other else, and then you want to have those two microcontroller to connect each other, can do some synchronized work, and then you can do by using this communication pin. So if it's digital input or output, it's clear, just 0 or 5 volt, it's clear. Now I want to cover the PWM output. The PWM can go from 0 to 100% is by modifying the data cycle, which is 50% data cycle. That's mean for one period, the 50% on and the 50% off. The 75% of data cycle means for one same period, the same length, 70% of time is for on and 25% for off. And in opposite is 25% data cycle means for the same length of the same periods of time, 25% times on and 75% is off. So by having this thing, then you can control, let's say, the speed of the motor or the brightness of the lamp. Let's say if you put this 50% duty cycles for the lamp, then it's become a little bit dim. If you want to make it brighter, then you can apply 75% duty cycle, then it will be brighter. If you want to make it quite dim, then you can just apply 25 duty cycles, then the lamp will be very dim. If you apply 0% duty cycles, that means all of the time period will be off because the on is 0% or nothing, then the lamp will be totally dark. If you apply 100% duty cycles, that means during this period of time it's always on, then the lamp will get the maximal brightness. That's for the PWM output. For the communications, this is just illustrations. I'm not going to cover this in detail for now. I just want to highlight that for the serial communication, the name of the pin is TX. For the SPI communication, the pin name is serial clock, MOSI, MISO. For the I2C connection, the SDA, SCL. Okay. How it's connect between one device to other device, just like this. But in details, what is the SPI? What's the difference between I2C or serial connection? I will be covered in the next few weeks. So I already told you that you can connect the input and output devices through microcontroller pin. But that's not the only case. There is also what they call Arduino Shield. For this case, you don't need to do some soldering. You don't need to buy some cables. You just buy the Arduino Shield and just plug to the Arduino board. So, and that's it. The Arduino Shield is designed for the entry level for the microcontroller learner. So because it simplifies many things, you just can, let's say, if you want to control the motors of the Arduino, you just buy the motor driver shield and just connect to the socket, and that's it. You don't have to get some cables. You don't have to bother which pin has to be connected. Just buy this one and then connect, and that's it. But as you can see, the choice of the shield is not many. So this is good for the learning, for the basic learner, because it's can connecting input output without cable, just plug, no soldering. And then if you have more than one shield, it can be stuck. So you can put this one on the top of this one, it's fine, it's still connected. Okay, I think it's enough for today. Thank you and see you next week.